Alright, we're going to look at your functions test review. This is what I gave you in class, so this is your review for your functions test. What we're going to do here is start off with number 1. This is a composite function right here, and basically we're going to take the, we're going to interpret what this means. It's going to be h of g of x is what I'm saying that is. So what I'm going to do is I'm going to plug x as the input for g. So we're going to turn this input x into an x, but that doesn't really do anything. So the output will be what we have here, g of x, which is 3x plus 6. This right here is 3x plus 6. So this is going to go into h, that's what I'm saying. So the input here, right here, for h, this is going to become 3x plus 6 instead. It's going to go into that x. So what I have here is 1/3 times 3x plus 6. And then don't forget that that's a minus 2 after that. So we'll distribute. Hippity hoppity, distributed property. 1/3 of 3x is just going to be x, and 1/3 times 6 is 2. Or it's the same thing as 6 divided by 3. So then we have that, and then we subtract 2 at the end. Plus 2, negative 2, these are going to cancel out. This answer will be x. What this suggests to you when you get an output that's the same as the input. The input's x, the output is x, that these two functions, h and g, are in fact inverse functions. Okay, inverse functions. Now, if I just scoot you over and look at number 4 here, I see this. I see that I switched g and h around. That's not going to change the answer, though. If they're inverse functions, whatever I plug into this composite is going to come out as the same. So let's go ahead and do number 4 next, and we're going to see that this is actually g of h of x, and we're going to plug x into h. So this right here is going to stay as an x, and that means this whole thing now is going to go into g. So I'm going to plug this all the way into this x right here, the other way around. So now what I have here is 3 times 1/3 x minus 2, and then plus 6. And then I'll distribute that way. And I'll say 3 times 1/3 of x is going to be 1x, and 3 times negative 2 is negative 6. Don't forget to add the 6. And what you see again is that these 6's will cancel out, and your answer is just x. Okay, it'll work out either way. I already knew this answer was going to be x because h and g are inverse functions. Okay, let's go down to number 2. This literally translates to f of x times g of x, if you understand your function operations. So we're going to take this f of x and multiply it by g of x. It's basically just a FOIL. That's all it is, or a distributive method as they call it. X minus 3 times 3x plus 6. And then we'll say x times 3x is 3x squared. And x times 6 is 6x. And then negative 3 times 3x is negative 9x. And then we got negative 3 times 6, which is negative 18. We'll combine like terms. 6x minus 9x. And we'll get 3x squared minus 3x minus 18. And that really is your final answer. Okay. If you wanted to, you could factor out a 3. I'm not going to make you, but if you did, you'll get something like this. X squared minus x minus 6. And you could try to factor that if you wanted to, but really this is all I'm looking for, honestly. Let's go and do number 5. This is another composite function. X goes into f. That output will go into p. All right. So x is already being inputted into f right here, so this is going to be x minus 3. That's going to get plugged into p. So let's see if I can move this out of the way. So we're going to plug it into this and this x minus 3. So what I have here is 2 times x minus 3 squared minus 5x minus 3. I'm going to look at this portion first, and I'm going to remember that x minus 3 multiplied by itself is just another FOIL. Or it's going to be x times x, which is x squared, x times negative 3, which is negative 3x, negative 3 times x, which is negative 3x, and negative 3 times negative 3, which is 9. Okay, I simply quickly write this as x squared minus 6x plus 9, and you really should be able to do that in your head after some practice. And then we have this. This is actually written incorrectly. This is negative 5 times x minus 3. That goes right there, remember? That's the input x minus 3. And then we're going to put minus 3 after that. That's what we're going to actually have here. That x is going to turn into an x minus 3. So we got negative 5 times x, which is negative 5x. Negative 5 times negative 3, which is 15. And negative 5 times negative 3, which is, I'm sorry, just negative 3 on the end. That's what we have. So we'll distribute this and see what we can figure out. We got 2x squared, 2 times negative 6x, which is negative 12x, 2 times 9, which is 18, and then minus 5x here. 15 minus 3 is actually a 12. And we'll combine like terms and we'll be finished. This is the only x squared term that I have, so this is 2x squared. That's all I got. Negative 12x minus 5x is actually negative 17x. And then 18 plus 12 is 30. And then your answer is this. 2x squared minus 17x plus 30. Alright, let's keep moving. P over f of x. So we got p of x literally divided by f of x. Alright. If you recall, p of x written on the top of your paper there is 2x squared minus 5x minus 3. And that will be divided by f of x, which we know is x minus 3. So this is the tricky part. You got to factor this. I'm going to change my pen color a little bit here, see if that helps. Let's make it blue. All right. So what I'm going to do is I'm going to multiply the first and last coefficients. So this is going to give me 2 times negative 3, which I know is negative 6. And then I'll copy the rest. I got negative 5x in front of that, and then x squared. But when I'm doing this, I'm actually going to change this 2 right here into a 1. That makes this much easier to factor because this is tough to factor. All right, so this is called the slide and divide, or the bottoms up technique that I call it. So what we're going to do basically is we're going to take this and we're going to try to factor it. So what does this factor into this? We're going to say factors of negative 6 that add to make negative 5. So what is that going to give me? That's going to give me negative 6 and positive 1. Negative 6 times 1 is negative 6, and negative 6 plus 1 is negative 5. These are not the real factors, okay? When I multiplied 2 and negative 3, I changed the question. So let's change it back. We're going to divide these numbers by this number in front that we started with, which was 2. So 6 divided by 2 is negative 3. And this 1 over 2 doesn't reduce or divide evenly, so this 2 is going to come up in front of the x. And we're going to call this 2x plus 1. These are your actual factors, okay? I turned this whole thing right here, into what? This thing right here. On the bottom, I still have x minus 3. And what you should notice is that this and this are going to do what? They're going to cancel out. So this answer is going to be 2x plus 1, or something close to that. Anything you got that this is actually identical to that will be fine. If I say on this one, number 6, a composite f of h of 6 is really what this means. So let's find h of 6. We're going to plug 6 into h. Just take a look at h again, okay, because I've already forgotten. H is up here. It's 1/3 x minus 2. So we're going to turn that x into a 6. So this is going to be 1/3 of 6 minus 2. 1/3 times 6 is simply 2. 6 divided by 3. And then 2 minus 2, this answer will be 0. That 0, what I'm telling you is this whole thing right here is 0. Now that's going to go in the input for f. Okay? Now keep in mind that, remember, f is x minus 3. So now this is f of 0. Okay? Because this output is now the input right here. And that's going to be now 0 minus 3. So this answer is simply negative 3. That's your solution for number 6. Okay? The composite function. Alright, let's turn the page. And I think we have some domain and range questions in handy. Remember, we've done all these in class, but I'll go over this again, just in case you want to see it again. So we're going to do the domain and range for each. So domain, range. There we go, range. And let's change the pen to something else. Okay, green. So the domain, this is going to stretch out to negative infinity pretty much. And this is going to come, this is going to go this direction to the left, negative infinity. As we move to the right, we're going to have to stop where the graph stops, and we're going to have to stop here at negative 4, because the graph stops here at negative 4. So I have to go from negative infinity to start with, as far as I can go, which is negative 4. And then I'll put an inclusive here, because that's a closed circle. And then I'll pick it up again. That's actually negative 1, open circle at negative 1. And then I'll move to the right till I get to 2. And then I'll put a closed brace, because 2 is included because it's a closed circle. And then I'll have to stop. There's a break in the graph here, and then I'll have to pick it up again at 4. So I'll union again, and this time I put an open brace because it's an open circle at 4. And this will continue onward. This graph will go onward to infinity. So this will be infinity, and that will be your domain. Okay? Alrighty. Let's take a look at the range. And let's erase some of this mess that I've made here on the graph so we can see kind of what's happening. Alright. Let's get rid of all that. Now let's try this again. Let's get my pen back. Let's just change it to, I don't know, black is fine. Okay, what's the smallest range value on my graph here? Okay, the smallest y value that I see here is in fact negative 4. Okay, just because it's not included here doesn't matter, because it is included here. If it's included anywhere, you should include it into the range. So it's going to be negative 4 inclusive. Now, as I move up this graph is going upward, upward, upward toward infinity. Okay, so I think about these points over here on this graph, but they're also already over here, the same points. These points on here on this part of this interval are also right here on this graph already. So what I'm saying is this interval right here is encompassing all the points that are in here and in here. These intervals here are included in this big interval that we already have. So this is going to simply go to infinity, and all these range values are valid. So the answer is negative 4 to infinity inclusive. The negative 4, I mean. So let's go down to number 8, and we're going to say domain and range again. And we're going to say range. I'm not really sure why it's doing that. Let's see. I'll just copy it. There we go. Oops, let's not drag that. And let's go back to my pen. And we'll say, all right. Let's go to from left to right here. So this thing is going to jet out this way to negative infinity, and we're just going to move along the x-axis until I have to stop where the graph stops. Graph stops here, so it's negative 3. So from negative infinity to negative 3, we'll have domain values. Negative infinity to negative 3, and we'll include negative 3 because of that closed circle. We'll pick up again at negative 2 and go on the way to 2 because this whole graph, all these x values are included. So I'm going to say, okay, well, union negative 2 to 2. And this is a rounded brace, and this is a closed one. This pen is acting kind of strange. This is a closed one. And then we're going to move over to 3. This is another open brace because 3 is not included because of the open circle, and this graph is going to go off this way forever to infinity. So we're going to say to infinity. Okay, and that will be the domain. Let's talk about the range now, after I erase some of these markings that I put on here. Alrighty, let's just kind of erase some of that stuff. And then we'll look at the range. Pen. Okay, so what is the smallest y value that's actually on my graph? I see here at negative 5, I have an open circle. So negative 5 is not included there, but it is included here, where there's a closed circle. So negative 5 is part of the range, and this graph is just going to increase upward, onward, and upward to infinity. You know, in the y direction, as I go up, the numbers are going up to infinity as this thing continues to go up. All these points right here on this graph and all the y values on this graph are already going to be on this graph over here anyway. The intervals here are included on this interval over here. So what I'm going to say then is it goes from -5 upward to infinity, not inclusive on the infinity. So that's simply the range. There's nothing really else to it. Okay, we're going to say number 9. Going through the motions here, number 9. Range to go with it. Okay, let's change the color. So the domain, reading from left to right, I'm going to start at -6 and move to the right along the x. And do I have to stop? I stop here at 2 just to take a look at it. I don't know why it keeps doing this. Let's see, we just copy that. And I look at -2. It's not included here, but it is included here. So you're thinking, okay, it's not included at 2, but even though it's not included here, if it's included anywhere, and this value 2 is included right here, it's part of the domain. So there's actually not a break in the domain at all. It simply goes all the way straight through without actually losing a value. So it's simply going to go from -6 inclusive because of the closed circle, and it's going to go all the way to the right to infinity. It's going to go this way forever. And that's simply the domain. Okay. On the range, if I'm looking at the range, let's take a look at that real fast. The range here, what's the lowest y value that I see on my graph? If I look at this graph, the lowest y value I see is right here. And that range value is here at 0. Okay. And then I'm just going to move up the graph and hit all these y values as much as I can. And they're going to go all the way up to infinity. Okay, these y values right here are the same as these y values here. So this interval is going to encompass all of this part of the graph. So simply from 0, inclusive, remember, this is a closed circle. If you don't see an open circle, you assume it's closed. So it's inclusive. So we're going to include 0 all the way to infinity. And that's simply your range for number 9. All right, let's turn the page. Let's go on to number 10. Okay, number 10, let's take a look at this. We have a domain and range portion again. So domain, range, see how that works out. Okay, looking at the domain, I'm going to see that this actually stretches out to -infinity. And I'm going to move along the x-axis here until I have to stop. I have to stop here at -1. Because this graph is not allowed to cross -1. There is a vertical asymptote right there. Okay, will not cross -1. So it'll go up as close as it can, but never actually reach it. All right, so remember, I'm not going up on the domain, I'm going from left to right. So this has to go from all the way to -infinity, but it stops here at -1. Okay, so keep that in mind. So we're going to say this goes from -infinity, and then it has to stop here at -1 because it can't cross this line. Now, where is it going to pick up again? We don't include -1, remember? It's a round brace. We're saying it doesn't include. Where it picks up again is the other side of -1, which is right here. And it's going to come up. It's going to come up this way, and then go off forever in this direction toward infinity. So it picks up again at -1, but the other side of it. So we say -1 again, but this time to infinity. So another way of looking at this interval notation, what we have here, is all values from -infinity to infinity except this -1, which is not included. -1 is the only value of x that is not in the domain. That's a real number. Okay, so that's how you do the domain. Let's take a look at the range. I'm going to change the pen color again. And let's actually erase first. Okay. And we will do that. All right, so let's see, purple. Okay, so this, we're going to go from bottom to the top. So we're going to start at -infinity. This thing is going to move up as far as it can, and then it has to stop. It cannot cross this boundary right here. There's a horizontal asymptote here that it cannot cross, and that is at it's a +1. Okay, so I'm going to say from -infinity to +1, not inclusive, because this graph actually is never going to reach that horizontal asymptote. And then we're going to union this, and it's going to pick up on the other side of +1 on the y-axis, and it's going to move up to what? To infinity. Okay, so we're going to say from 1 to infinity. So it's like saying all values from negative infinity to infinity, not including this positive 1, because right here the graph isn't defined on this horizontal imaginary line, this asymptote. Okay, so that's really what you're looking at. I do hope you understand that, because that might be the trickiest part of domain and range, and it's really not that complicated if you kind of understand how asymptotes work and how to do this interval notation. That's also kind of tricky. So try to be careful. Let's move on to the last portion. And this portion is the tough part. This is the relative extrema.
Good night, Derek.
Good night. Relative extrema, maximums, and minimums. Let's have a look at that of the following functions. You must justify the coordinate is a maximum or minimum. So I want you to find the relative extrema. Okay, so this is a function. We have no idea what it looks like, but let me give you an idea what I'm talking about. When I'm talking about relative extrema, if I just make up a graph, this is kind of what this graph should look like. Okay, my extrema are the local maximum and minimum points, for instance. So if I imagine there is a bunch of tangent lines, okay, a tangent line will hit the graph only at one point. So if I have a tangent line across here, and I have a tangent line across here, and I have a tangent line across here, this slope of this tangent line will be positive. This slope of the tangent line, because it's increasing, will also be positive. This line is decreasing, so it'll be negative, this slope. But at the maximum and minimum, we have horizontal lines, tangent lines. And the slope of a horizontal tangent line is 0. Okay? So if I can actually figure out the slopes of these tangent lines, and they go from positive to 0 to negative, where it was 0 here is called a maximum. And if it goes from negative to 0 to positive, this where it was 0 is called a minimum. That's the idea. Okay? But to find the slope of a tangent line, we have to use this calculus concept, which is called a derivative. Okay? Something that Isaac Newton figured out centuries ago. And this is basically how we're going to do this. So we're going to have f of x, and we're going to take a first derivative, which is a calculus concept. This is the only calculus we're going to make you learn for pre-cal for a long time. So we're going to say f prime of x. That's a first derivative. And to take a first derivative of a polynomial is pretty straightforward. All we really have to do is write, we'll do some little operation here. We're going to say the coefficient times the power. It's 3 times 1. So 1 times 3 or 3 times 1 is 3. We'll write the x like we're supposed to, and then we're just going to take 1 away from the power. So now that's going to go to 2. 3 minus 1 is 2. We keep this process going all the way throughout. Alright, so we got 2 times negative 6 next, which is negative 12. Take 1 off the power, so it's going to be 1. Here the power is 1, so it's 1 times 9, which is 9. And if I take 1 off that power, it becomes what? It becomes 0, which means this x kind of disappears, because x to the power of 0 is the same thing as 1. The derivative of a number is always 0, okay? So we don't write it. So this is actually a derivative right here. It's 3x squared minus 12x plus 9. The derivative, this first derivative, is the slope of a tangent line. Okay? Because this is the slope of a tangent line, and I want my tangent line slopes here and here to be what? To be 0 and 0, I will set this tangent line slope right here, which is the first derivative, equal to 0, because I want it to be 0. Because that'll tell me the locations of these what? These x values, where the minimums and maximums are occurring. So that's the idea. So I'll set it equal to 0, and then I'll try to factor this out. Actually, I see that every coefficient is divisible by 3, so I'll take out a 3. So I have 3 times x squared minus 4x plus 3. If I factor out a 3 out of that. And now I'm going to factor this further. Okay? I'm going to factor the inside of this right here. And I say that's the same thing. Factors of 3 that add to make negative 4. That's going to be what? Negative 3 and negative 1. Negative 3 times negative 1 is 3, and negative 1 minus 3 is negative 4. So I got 3 things. This, and this. And they all have to equal 0. 3 doesn't equal 0, so there's not much I can do with that. But these two guys can equal 0. If I say x minus 3 equals 0, and I solve it, then x has to obviously be what? Positive 3. Okay, because 3 minus 3 is 0. So if I plug in a 3 here, 3 minus 3 is 0. If this part is 0, 0 times this will still give you what? 0. That's the idea. That's what I'm saying to you. Now I'm going to say x minus 1 is also equal to 0. And I solve this. That means x has to be positive 1 because 1 minus 1 is 0. What I mean by that, I'm going to plug 1 back into this. 1 minus 1, this will become what? 0. And 0 times anything will be 0. So if I plug either one of these x values into this equation, this whole thing is going to equal 0. That's the idea. So these are very important x values, 3 and 1. Those are the locations of my maximums and minimums. The problem is I actually just don't know which one is a maximum, which one is a minimum, or anything else. So I have to figure this out without using a graph. Of course, I don't have a picture, really. So I'm going to do what is called a sign chart, okay, so of the slopes. So let's make a number line, and we got 1 and 3. So we got 1, we got 3, we have the slopes that we need, and we'll plug in stuff, all right? So if I plug in 1 or 3 into this derivative right here, the answer we know is going to become 0. So that's the slope at 1, and that's the slope at 3. These are the locations of my maximums and or minimums. But I needed some test values around these values because I need to know what the slope was before and after these points. So an x value that's below 1 is in fact 0. Okay, so I'll plug in 0, this x value, into this derivative right here. So I'm going to say this x is a 0, this x is a 0. So this is 0 minus 0 plus 9. The answer is positive. It's plus 9. So this sign is positive. If I pick a value between 1 and 3, like 2, and plug that in here again, plug this 2 into the derivative, and figure out what comes out. So I got 2 squared, which is 4, times 3, which is 12, minus 12 times 2, because that's a 2, remember, which is now 12 minus 24, so that's negative 12. And negative 12 plus 9 will be negative 3. So we don't really care what the number is, we just know the answer is going to be negative. I need to pick one more value that's bigger than 3. Let's pick 4, and we'll plug that in here. And I'll write it up here just for fun. This is going to be 3 times 4 squared minus 12 times 4 plus 9. I'm just substituting 4 into these x's right here. Alright, this is going to be 4 squared is 16. 16 times 3 is 48. Negative 12 times 4 is also 48 plus 9. Oops, I don't want that. And these are going to cancel. So this is a positive answer, like that. So it goes that way. Now I told you if I go from negative to 0, from positive to 0 to negative, like I am here, positive 0 to negative, this is a maximum. So at 1, we call this a maximum at 1 right here. Okay. And if I go from negative to 0 to positive, like I am here, negative to 0 to positive, this means that 3 is a what? It's a minimum. So I have this. So if you give me these two answers, you're done for the question. That's all I really want. Okay? So let's go on and do the next one. That seemed like a lot of explanation, but we're going to try to go a little faster on this one now without all this talking. Okay? So let's see if we can just kind of go through it and just go through the process. And let's see what happens. Okay, so I got g of x. We'll take the first derivative. Go a little faster. First derivative. Remember, we're going to say negative 1 times 3, which is negative 3. Take 1 off the power, 2. 2 times negative 3 is negative 6. Take 1 off the power, so that's this 1. The derivative of a constant is nothing, so this is your derivative right here. We have it. Okay? We want this derivative to equal what to find the maximum minimums? We want it to equal 0. So now I have this. I can actually see that I can factor something out of both of these terms. I can factor a negative 3x, as it turns out. So I'll factor a negative 3 out. And what's going to go in there? What do I multiply negative 3x to get negative 3x squared? I just multiply it by x. That's it. What I multiply negative 3x by to get negative 6x? I multiply it by a positive 2. So this is my set of factors here. So what I have here are two factors that I both want to equal 0. So that means negative 3x should equal 0 or x plus 2 should equal 0. Okay, so imagine that. If I have negative 3x equaling 0, that means x would have to be what? It would have to be 0. If I have x plus 2 equaling 0, then x would have to equal negative 2. Which means if I plug in either one of these values into this function, it'll equal 0. That's what I mean by that. So I have two answers here. I have one of them x equals 0, and the other one x equals, oops, let's get this out of the way here. The other one equals negative 2. Now, which one is a maximum, which one is a minimum? Because one of them is a maximum, one of them is a minimum, maybe. We don't know. So we have to do the number line thing again, okay, just like we did before. So we'll put down negative 2, and we'll put down a 0. All right, so think about this. We need to pick some values that are, in between these and close to them on either side. So a value that's less than negative 2 would be negative 3. A value between negative 2 and 0, negative 1 is a nice one. And a value bigger than 0 will be 1. And we'll just go along the number line this way. And we'll pick some stuff here. I need to get rid of this here. I don't know how to get rid of that. That seems to work. Okay. And then we'll say, okay, if I plug in these values, negative 2 and 0, into this derivative, the slope of that tangent line will be 0. If I plug in negative 3, if I plug in negative 3 out here, what's the slope going to be? So we're going to say, okay, what is negative 3 times negative 3 times negative 3 plus 2? Uh-oh. Keeps moving my selection tool. Plus 2. Okay, sorry about that. So negative 3 plus 2 is negative 1, and negative 3 times negative 3 is positive 9. So if I say positive 9 times negative 1, this is going to give you what? It's going to give you negative 9. Okay, but the answer is negative. That's the important thing to notice here. So this answer will be negative right here. All right, so it goes from negative to 0. I want to figure out what that is right there. So let's actually erase that part out and try it again. Our next test value is negative 1 here. So we'll try that out. So now I have negative 3 times negative 1. I'm substituting negative 1 in for x because that's my next test value. And I'm going to have times, oh my goodness. Uh-oh. Okay. I'm going to have negative 1 plus 2 equaling 0. So negative 1 plus 2 is 1. And negative 3 times negative 1 is 3. So if we multiply these together, oops, it'll give you the value of 3. And this answer, this 3, is actually a positive number, so this will be positive. Now let's go ahead and plug in the last one. With any more difficulty, we're going to have 1. We're just going to plug that in. So I got 1 plus 2, which is 3, and negative 3 times 1, which is negative 3. What happens if I multiply negative 3 by 3? I'll get a negative 9, so the answer will be negative. So if I go from negative to 0 to positive, remember it's like going down, and then 0, and then positive. This point right here is going to be a what? It's going to be a minimum. So at negative 2, that is a minimum. And then I go from positive to 0 to negative, so it's like going from positive to 0 to negative. So this point right here at 0 will be a what? It'll be a maximum. And these are what I'm looking for in your solutions, okay? And then we're down to the last question on this test review. And let's see what we can do. Hopefully we can do this without too much difficulty with these pens. Let's take a look. Let's try the derivative. G prime. We got 4 times 1, which is 4. And then we'll take 1 off the power, which is 3. And I got 2 times negative 2, which is negative 4. Take 1 off the power, so that's 1. The derivative of 3 is nothing, so this is your derivative. All right, I notice here, though, that I want this to, of course, equal 0 to find my maximum and minimum points. And I'll factor out a 4x. So 4x times what gives you 4x cubed? 4x times x squared. 4x times what gives you negative 4x? That'll be a negative 1. Okay? Now, from here, I'm going to factor this further. I'm going to say, okay, 4x, x squared minus 1 is a difference of squares. It's actually an algebra rule. to say that a squared minus b squared is the same thing as a plus b times a minus b. It's a difference of squares rule, which you should have learned in Algebra 2. So we're going to say, okay, that's going to be the same thing as x plus 1 times x minus 1. Negative 1 times 1 is negative 1, and negative 1 plus 1 is 0, which is why there's no x term, because it's 0x, which means it disappeared. That's how that works. So now this is going to equal 0. We'll take all three of these and set them all equal to 0. So I have 4x equals 0. I got x plus 1 is equal to 0. And I got x minus 1 equaling 0. Okay, so what times 4 gives you 0? That means your first answer will be 0. Okay, right here, what do I plug in for x plus 1 to get 0? X is going to equal negative 1. And here, 1 minus 1 will give you 0, so your third answer is 1. So we actually have 3 maximums and or minimums in this particular graph. Now we just have to determine where they are, which one's a max, which one's a minimum. And then we'll be done with this entire review here. So let's make the number line. I have negative 1, 0, and 1. And what I need are values that are in between them and on either side of them. So we'll just pick whatever we like. Negative 2 is a nice one. Bigger than 1, we'll pick 2. In between negative 1 and 0, that should be a negative 1/2. And in between 0 and 1, we'll make a positive 1/2. So I'm going to plug this negative 2 here into this, either this function, or we can plug it into here. Probably easier, because these are the same. So plug negative 2 into x. So we got 4 times negative 2, which is negative 8. Negative 2 squared, which is 4. And 4 minus 1, which is what? Which is 3. Negative 8 times 3 is negative 24, so this answer will be negative. At negative 1 already, since that's one of our answers, we know the slope there will be 0. At 0, it'll be 0. Oops, let's get this out of the way. Uh-oh. I want you to copy that. Okay. That seems to work. And if I plug in 0 there, I'll get 0. If I plug in 1 into this whole thing, I'll get 0 as well. Well, what will I get at the halves? Negative half and positive half. Alright, so if I plug in a negative half, let's actually figure that out. So right here, I'm going to plug it into this x here and this x right here. So I got 4 times a half squared minus 1. 4 times a half is 2, and a half squared is a fourth. But a fourth minus 1 is going to be a negative answer. So I'll have a negative times a positive, which will give me a negative right here. I'm sorry, let's see, is that right? Yeah, sorry, this is a negative half. That's where I went wrong. That's negative, that's negative. So I'm going to get a negative answer here, and then I'm going to get a negative squared, which becomes positive, and then minus 1, so it's a negative. So I'm going to have a negative times a negative, which will give me a positive answer, is what's going to happen here. If I plug in a half, which is your next test value, if I plug in a half, let's get another pen, then I'll have 4 times a half, which is 2. Half squared is a fourth, minus 1, that'll be negative. Okay, so I get a positive answer times a negative answer, whatever that is, so multiply that, and that's going to give me a negative answer. And if I plug in 2, I'll get 2 squared, which is 4, minus 1, which is 3, and then 3 times 4 times 2. 4 times 2 is 8 times 3, which is positive 24. That's going to be a positive answer. The sign changed from negative to positive. Remember, from negative to positive, that means that this one here is a minimum at negative 1. Positive to negative, if I go from positive to negative, 0 is a maximum. And then if I go from negative to positive again, this is going to be another minimum here. So your answers are here, like that. And let's move that out of the way. Oops, I can. Maybe not. Okay? So that's how that works. Yeah, sorry that was kind of tough, but I appreciate you watching this. I hope that helps out. That's your test review. And good luck tomorrow. I'm sure you're going to do very well. Thanks a lot.